So the binomial distribution is all about repeating an experiment a certain number of times, and the outcome of the experiment is either a success or a failure. And in order to kind of build up to the formula that we're going to use, let's look at a simplified version. So in this version, we're going to repeat an experiment twice, and each time we do the experiment, it's either going to have a success or a failure. And the probability of success is 0.3. So our random variable x is the number of successes that we have when we do this experiment twice. Rather than experiment, the word that we often use is a trial. So we can visualize what the possible outcomes are by drawing a tree diagram. So on the first trial, you could either have a success or a failure. And on the second trial, you could either have a success or a failure. So this means we've got 4 different outcomes. We could either have a success followed by a success on the first trial and then a fail and a success, or a fail followed by a fail. And we could work out the probabilities of each of these by just multiplying along the branches. So 2 successes is a success followed by a success, so that's 0.3 squared. Success followed by a failure is 0.3 times 0.7. Failure followed by success is 0.7 times 0.3. And 2 failures is a failure probability times by a failure, so 0.7 squared. What our aim is to come up with the probability distribution of this random variable x. So underneath, let's write a probability distribution table. So remember, x is the number of successes that we have. So let's write down how many successes we have in each of these outcomes. So in this outcome, we had 2 successes. Here we had 1 success, here we had 1 success, and here we failed both times, so we had 2 failures. So our possible different values of x, our sample space, x could have 0 successes, 1 success, or 2 successes. So let's write down the probability of each of these x values, these specific little values of x. So the probability of having 0 successes, well, that's just failing every single time, so failing twice, which is 0.7 times 0.7, 0.7 squared. And the probability of having 2 successes means that you have to succeed both times because we're only doing 2 experiments, so that's going to be 0.3 squared. Now, these probabilities here are the probabilities associated with having 1 success. So these probabilities are the same as each other. They're both 0.3 times 0.7. It doesn't matter which way around you do your multiplication. But we've got 2 lots of them. So if we want the probability of having this event happening or this event happening, we would just add them together. So that's equivalent to saying I've got 2 lots of 0.7 times 0.3. So we've got 1 success probability times 1 failure probability. Now this number 2 comes about because it's the number of ways in which we could have 1 success. And the way that we're going to think about where this number 2 comes from, you can think about we've got 2 outcomes. The outcome of the first experiment and the outcome of the second experiment. And in order for x to be 1, so having 1 success, we need to choose one of these boxes to be a success. So obviously our 2 different outcomes are we could either choose the first box to be a success or the second box to be a success. So there's 2 ways of doing that, which is why we had 2 ways on our tree diagram of having 1 success and 1 failure. Well, obviously that's really easy to work out when we've only got 2 trials, but it's going to be more complicated when we have more trials. So the way that we want to think about this is we've got 2 trials and we want to choose one of them to be a success. So that's 2, choose 1, or you could write that as 2, choose 1. And that does give you the answer 2. Okay, so next we're going to try and make it a little bit more complicated, and we're going to do 3 trials. So we're going to repeat the experiment 3 times. And this time we're going to make it a little bit more general and say the probability of success is P. So that means that the probability of failure is 1 minus P. So I've already, because these branches have to add up to 1. So I've already labelled my branches success is P and failure is 1 minus P. So you can see that we've got all these different outcomes. And our aim is to work out what's the probability distribution of X, where X is the number of successes. So we want to ask the question, for example, what's the probability that over these three experiments I have 2 successes? So let's write down what X would be equal to for each of these events, so the number of successes. So we could have 3 successes, 2 successes, 2 successes in this case, 1 success, 2 successes in this case, 1 success in that case, 1 success in that case, and here all of them are failures, so 0 successes. So you can see I could either have 0, 1, 2 or 3 successes. So they're my possible values of X, the number of successes. So in our probability distribution table we're going to have 0, 1, 2 or 3 successes. And we want what's the probability of having each of these successes. So having 0 successes is really easy because we've got 3 trials, and if we have no successes, that means we're going to go down the failure branch 3 times. So that's going to be 1 minus P times 1 minus P times 1 minus P, which is 1 minus P cubed. Okay, so that's really simple. And it's also quite easy to see what the probability of having 3 successes is. Well, we're doing 3 trials and all of them are successes, so we're going to go down the success branch 3 times. So that's just going to be P times P times P, or P cubed. These 2 in the middle are slightly more complicated. Let's look at the probability of having just 1 success. So our outcomes associated with having 1 success is this outcome, success followed by 2 failures, or having the success in the middle, or having the last trial as a success. Well, notice that each of these probabilities are the same as each other. And the reason why is because the order of multiplication doesn't matter. Either way, I'm going to go down a success branch and 2 failure branches. So I'm going to have P times by 1 minus P times by 1 minus P, but I'm going to write that as P times 1 minus P squared, because I'm going to go down this branch times by this branch times by this branch's probability. And this one, you could write that as exactly the same because the order of multiplication doesn't matter. So here I'm going to add up each of these probabilities because I want either this event or this event or this event. So I add up those probabilities. So that's the same as saying I've got 3 lots of P times 1 minus P squared, 3 lots of that probability. So it's fairly easy to see why we have P times 1 minus P squared. This 3 might not be as obvious. What we want is an easy way of finding out this 3 without having to draw out the tree diagram or draw out all the possibilities. Well, again, we can think about this as we've got 3 trials and we want to choose just one of those boxes to be a success. So there's 3 different ways of doing that, which we've seen above. We could choose the first box to be a success, the second box to be a success, or the last box or trial to be a success. So there's 3 different ways of doing this. Well, the mathematical way of working this out would be to say we've got 3 trials and we're choosing one of them to be a success. So that's 3 choose 1, or 3 choose 1 there. Let's do the same with X being 2, so having 2 successes. The outcomes associated with that is this outcome, or this outcome. Now, each of these probabilities, you're going to go down 2 success branches and 1 failure branch. So you're going to do P times P and then times by 1 minus P. So P squared times 1 minus P. But notice again, we're going to add up these probabilities and there's 3 lots of that probability. So here we're going to have 3 lots of p squared times 1 minus p. So you can see that we've got p squared here because we've got 2 success branches, and just 1 minus p because we're going to go down the failure branch just once. And this 3 is because there's 3 ways of having 2 successes. So again, you can think about this as we've got 3 trials, and we want to work out how many different ways are there of choosing 2 of the trials to be a success. So you can see from our tree diagram, you could either choose the first 2 to be a success, the first and the last one to be a success, or the last 2 to be a success. So again, there's 3 ways of doing this. Well, we don't really want to draw this out each time and work it out. So the mathematical way of working this out is to say we've got 3 boxes and we're going to choose 2 to be a success. So that's 3 choose 2, or 3 choose 2 written like that, which is 3. So now we're in a position where we can look at the most general situation. This time we're repeating the experiment n times, and the probability of success is p again. So I'm not going to draw out a massive tree diagram each time because that's going to take a lot of time, and it's not going to be very easy to do. So let's look at some specific probabilities which are going to be quite easy. X is still the number of successes, so we're doing n trials. Let's look at what's the probability of x being n. So that means that we have n successes, or in other words, every single trial that we do is a success. Well, if you think about the tree diagram, we're going to go down the success branch n times, and we're not going to have any failure branches. So this probability is just going to be the probability of success to the power of n. Another easy probability to see would be what's the probability of having 0 successes, so the probability of x being 0. Well, that means that we're not going to go down any success branches, and every single branch we go down is going to be a failure branch. So I should probably write here the probability of failure is 1 minus p. So we're going to have n failures to have no successes. So these are 2 really easy probabilities to work out. Let's look at the probability of having little x successes. So this number of successes, let's write that down, x successes. So let's think about what branches we're going to go down. We're going to go down x success branches. So that means we're going to have p to the power of x, because the probability of each success branch is p. We're going to go down a certain number of failure branches, and if we're doing n trials and we've got x successes, that must mean we have n minus x failures. So we need to do this to the power of n minus x because we're going to go down that many branches, which are failure branches. And then finally, we've got to think back to this example here. We had a number in front, and that number came about because we need to work out, if you've got n trials, how many different ways are there of having x successes? Well, that's the same as saying you've got n trials and you're going to choose x of them to be successes. So that's n choose x. So you can think about this formula as this is how many different ways are there of choosing x of the n trials to be successes. This comes about because we've got x successes, and this represents the n minus x failures.